Welcome to this video. We are having a season 2 per se of solving a bunch of integrals and just practicing integration, deciding which technique to use out of all the techniques that you've learned, and maybe you have to use more than one. Maybe you don't have to use any, and just algebraic manipulation. All right, so this is section 7.5 in the James Stewart Calculus Early Transcendental textbooks, the 7th edition, I believe I have. So this is the section, as I said, about techniques for integration, strategies for picking the technique. Okay, so I'm going to go very slowly, or I'll try to go slowly, and I'm going to solve probably like 5 problems in this video, and I'll separate it into multiple parts. Okay, so let's begin with number 1. So it probably starts from easier and it gets harder and harder. So let's see how we do on the first ones, because these should be easier. We have this integral cosine x 1 plus sine squared x dx. Okay, so here I can already see that we can make a substitution. We let u be sine x, du is cosine x dx, and we have that exactly here. So we can rewrite our integral as 1 plus u squared, that's here, 1 plus u squared, and then cosine x dx is just du. Now this is easy to integrate, those are just powers, so it's u plus a third u cubed plus c, and then we got to back substitute, u is sine x. Sine cubed plus c, this is what I get. By the way, I'm doing this live, I'm not checking my answers against, I don't have the answer key, I'm not going to turn to the back of the book either, and for the sake of time, I'm not going to check Wolfram Alpha either. And so just double check my work for me, but this is how I thought through it. Okay, number 2, integral from 0 to 1, 3x plus 1 to the square root 2 power dx. Okay, so here you might get confused because why is it to the square root 2 power? Well, it's just still a number. Like if this was just squared, then you know how to do that. You could just, well, if it's squared, you just expand it out. But if it's like to the 200 power, you can make a substitution. So we're going to do the same thing here. U is 3x plus 1. Du is 3dx. Okay, so, it's a definite integral. We have to worry about our limits. Let's do that afterward. This is just u, so u to the square root 2 power. Dx is du over 3, so a third du. I always pull my constants out, so hopefully if you're watching this, watching multiple videos of mine, you see that it's always a habit of mine to pull constants out because it just makes the inside nicer and we can focus on the inside of the integral. Okay, now our limits. When x is 0, we plug into here. U is 3 times 0 plus 1, which is 1. When x is 1, u is 3 plus 1, which is 4. Okay, this is just a power, like up here. So we just use the power rule. So it'll be a third. It'll be u to the square root 2 plus 1 over square root 2 plus 1. Okay, we evaluate this guy from 1 to 4. Okay, this guy is a constant. We can move it out once again. So 1/3 times 1 over square root 2 plus 1. Okay, and then we have multiplied by, for the linear calculus now, 4 to the square root 2 plus 1 power minus 1 to the square root 2 plus 1 power. Okay, but this is just 1, but I'm just going to leave it like this. Okay, I don't think you need to simplify that much at this point in your math career. Okay, number 3, integral sine x plus secant x over tangent x dx. How do we solve this guy? Okay, so one technique is let's change everything in terms of sine and cosine instead of having tangents and secants. Okay, or you can change this in terms of tangent or secant, but that's a little more difficult. So let's change these in terms of sine or cosine. So that's sine x, that we leave that the same. Secant x is 1 over cosine x. Tangent x is sine x over cosine x. Okay, so since we have cosine on the bottom for these two, maybe let's multiply by cosine on top and the bottom. So let me write it like this. Okay, cosine x divided by cosine x, that's 1, so we're allowed to do this. Okay, so when we distribute, we have sine x, cosine x, plus 1 over the bottom we have sine x. dx. Okay, now we can divide through by the sine x. So we are just left with cosine x plus 1 over sine x is cosecant x dx. You should know these two. The integral of cosine is sine. Derivative of cosecant, antiderivative or integral of cosecant is plus ln of cosecant x minus cotangent x plus c. Actually, let me check that that is correct. Let me remember that. Hopefully I remember that correctly. Let's see. I just need to scroll in my book. Cosecant, yep, that looks right to me. Okay, so this is the answer. So notice we didn't even have to do any substitution. We just had to use an algebraic manipulation. All right, now let's do number 4. Integral of sine cubed over cosine. Okay, so how do we solve this? Well, this isn't just like a sine to the some power times cosine to the some power. What technically it is cosine to the -1 power. But we can use a similar strategy. Well, we can save one factor of sine out. I'm able to see that because, let me write it first. For sine squared here, we can just change it in terms of cosine. So it'll be 1 minus cosine squared. Okay. And now we can let u be cosine. Du would be minus sine. Okay, so our integral becomes 1 minus u squared is this term. Sine x dx, that's negative du. So let's move the minus sign out. I put it there. Over cosine x is just u. Okay, so actually let me move this negative term back in. I'm going to distribute the top so that I don't lose track of it. Okay, now we got this. Now this is easy. We can divide through by the u. So it'll be u minus 1 over u du. This is easy. It's just u squared over 2 minus log of u plus c. Don't forget your absolute value for log. Okay, now we got to back substitute. U was cosine, we said over here, right? So it's cosine squared over 2 minus log of cosine x plus c. That's what I get. Pretty simple, hopefully, so far. Okay, number 5, integral t over t to the 4th plus 2 dt. Okay, so here, what technique can we use? It's kind of looks like a rational function, but we don't have like quadratic factors in the denominator. We can't factor this. So we can't use the techniques that you probably learned in partial fraction decomposition. It's probably not that. It's very possible that you could do a trig sub, but that seems difficult to me, at least in my eyes, as I'm viewing this, because I do know how to solve this. What else technique do you learn? Is it a trig integral? Clearly it's not by parts, integration by parts. You could try it, but I feel like you might not get anywhere. It looks complicated also, because if u is t, dv is 1 over t to the 4th plus 2, that's hard to integrate, or yeah, so that probably might not be a good idea. So is there a substitution we can make? If u is the bottom, t to the 4th plus 2, du would be 4t cubed dt. We don't quite get that signature over here. So that substitution wouldn't work. But actually, let me rewrite this as t over t squared plus 2. This is the same thing as t to the 4th. Let me not forget the dt. So now, hopefully you can see a much better substitution. U is t squared, du is 2t dt. So our integral becomes, well, t dt is du over 2, so half du over u squared plus 2. This, you should recognize, is arctangents. So this half comes from here, these two halves, and then we have a 1 over square root 2 arctangent of u over square root 2 plus c, and then we got to back substitute 1 over 2 root 2 arctangent of t squared over root 2 plus c. That's my answer here. Okay, and I guess I'll do one more, number 6. Integral from 0 to 1, x over 2x plus 1 cubed dx. Okay, so how can we solve this? Well, let's go down. Let's again. Is it by parts? If u is x, dv would be this denominator, 1 over this denominator, or sorry, 1 over 2x plus 1 cubed. And that's not hard to integrate, but it's kind of tedious, so let's hold off on that. And probably not integration by parts. It's not a trig integral, clearly. Trig sub is not like a something squared plus something squared, so probably not that. Partial fraction decomposition, it probably is not that either, because it's not simple like, well, these are linear terms, so maybe it could work, but I probably wouldn't do that. Okay, so I don't know if I said this earlier, but a lot of these problems you can solve it in multiple ways. One way might be much more efficient and faster than others. So as I was saying, partial fraction decomposition might work here, but because I see a much faster way to do it. So I wouldn't choose that. And I was saying maybe by parts could work too, but again, I see a faster way. So what if we let u be 2x plus 1? du would be 2 dx. Okay, no questions about that, hopefully. That's just substitution. Well, when we substitute, let me worry about our limits afterward. We still have an x, so let's leave that alone first. Dx is du over 2, so half du over the bottom, we get u cubed. Limits of integration, when x is 0, u is 1. When x is 1, u is 2 plus 1, which is 3. So we still have this x in our integral that we want in terms of u. How can we get x? Well, here in this definition, we actually can get x. X would be u minus 1 over 2. So we can write x in terms of u, actually. So it'll be half integral 1 to 3. Let me write it like this. So the x is, we said u minus 1 over 2. And then we still have a du over u cubed. Okay, so this half I can pull out as a constant. So 1/4 integral from 1 to 3. U minus 1 over u cubed du. Okay, this is easy. These are just powers now, so that's why I think this way is faster. 1, 2, 3. We get 1 over u squared minus 1 over u cubed du. Okay, or if you want, you can write it as negative exponents if that helps you out. So I'll do it. U to the minus 2 minus u to the minus 3 du. Okay, now let's integrate. We get 1/4. It'll be u to negative 1 over negative 1. So it'll be negative 1 over u. Here would be u to the negative 2 divided by negative 2. So it'll become plus 1 over 2u squared. Okay, we evaluate from 1 to 3. Okay, so this is just 1/4. Plug in the upper limit, so minus 1/3 plus 1 over 9 times 2, which is 18, minus another parentheses. We plug in 1, so minus 1 plus half. Okay, I'll let you do the simplification, but this should be the answer. Okay, so here I chose to make a substitution because, well, I just tried it first and I see, oh, actually I can substitute this x also. I just had to do a little algebra, and then it made my integral very easy to solve. So as I said, there might be other ways to do this. It'll be good practice actually to try to do this in another way. If you already know that it's doable. I'm not going to do it here though, but this is the more efficient method in my opinion. Okay, so I will stop here for this part. Hopefully this was helpful. Please like this video as always if you found it helpful. And please subscribe also if you haven't already. And finally, please also look out for the next part where I'll do another maybe 5 problems or so. So I'll see you in that video. Bye.